Hello there, Mr. Sutton here with the AB Calculus 5.5 Extra Practice Number 2 solutions on RAM Part 2. On this problem, we're trying to figure out which of these integrals this expression is a Riemann sum approximation for. Now, it's worth noting that this is not one of those infinite Riemann sums with the limit as n approaches infinity and all that. This is just a RAM, essentially. And if we're going from 1 over 50 to 50 over 50, you could think of this as an RAM going from 0 over 50, which is essentially 0, to 50 over 50, which is essentially 1. And what are we doing with all these numbers, all these fractions between 0 and 1? Well, we're square rooting them. So this is all for the square root function. So putting it in this integral form then, we can say that our lower limit of integration is 0. That's our starting value that 1 over 50 is pretty close to. And our b value is 1. That's our upper limit of integration. The f of x is going to be the square root function. And you might be wondering, well, what about this 1 over 50 out in front? That's actually your differential. That's the base that's getting multiplied by all these heights that are being added together. Normally it would be base times height plus base times height plus base times height, but we've kind of factored this constant subinterval length of 1/50th out of all of these, so we just have a single base being multiplied by the sum of all the heights. So putting that all together, this is just then going to be the integral from 0 to 1 of radical x dx, which gives us answer choice, drum roll please, B. For this problem, I'm trying to take this weird limit summation kind of form and express it as one of these integrals. So I'm trying to put this in the form integral from a to b of f of x dx, essentially. So I need to pick out my lower and upper limits of integration along with the function. Clearly something is being squared, but is it a 1 over x or is it an x? So we'll figure that out in a minute. Let me start with my lower limit of summation. So basically, I'm trying to ask between what numbers are all of these things in here going to be? If n is approaching infinity, the first number that I'm inputting into all these squarings is going to be 0. 1 over infinity is essentially 0, so that's going to be my a value, my lower limit of summation. And if n is approaching infinity, what's the last number? What's the last input x value to this squaring function? Well, that's going to be 3n over n, which is just 3. So I'm going from 0 to 3 on this. And I'm taking all the numbers between 0 and 3, or at least numbers that are separated by a distance of 1 over n, and I'm squaring them. So my f of x is going to be x squared on this. And this 1 over n in front, that's just your differential. That's just what your input values are going up by each time. That's your delta x. So putting it all together, we have the integral from 0 to 3 of x squared dx, which gives us answer choice D. For this problem, I'm trying to convert this limit summation sort of deal, this series, into a definite integral. So I need to convert it into this format here. I need to pick a lower and upper limit of integration of function, and the dx is just going to be dx, but it corresponds to something over here. So for my lower limit, I'm basically asking what's the first input value to my function in this little summation bracket here. Well, the first thing I have is this 1 over n, but n is approaching infinity, so that 1 over n is really approaching 0. And then the last input here is n over n, which is really just 1. So 0 to 1, those are going to be my limits of integration. My function, what I'm doing to all the numbers between 0 and 1, is just square rooting them. So that's my f of x. And this 1 over n, that's your differential. That's what your x's are going up by each time you take one more step in here and make another little rectangle. Like we're going from 1 over n to 2 over n. The next thing's going to be 3 over n. You're just adding this delta x, this 1 over n each time. So putting it all together, we've got the integral from 0 to 1 of square root of x dx, which is going to give us choice B. For this problem, I'm trying to take this definite integral and convert it into one of these Riemann sums. So I'm essentially trying to put it in this format here. And my job really, because the stuff in the beginning is always the same, I'm just trying to pick out what my f of xk looks like and my delta x. And I always start with delta x because that's always the easiest thing to pick out, and it kind of determines how you write your function. So for delta x, that's in general going to be b minus a over n. So that's going to be just your interval length over n. 5 minus 3 over n, that's going to be 2 over n. And now that's going to help me establish what the rest of it looks like. So I need to do, for my xk here, that's just my a value plus my k delta x, this expression here. So my a value is that lower limit of integration of 3, and then I've got k times the delta x that I just found here. So I've got 3 times 2k over n, essentially. And now this whole unit here, this, whatever is happening to x in the integrand, that's going to happen to all of this stuff. So I'm now going to write out my summation as all of this stuff to the 4th power, because that's the function, that's the integrand, times 2 over n. And that is going to be answer choice, is it D? Yep, it's going to be D. These all look so similar. I was looking at B also, but B doesn't have the 2k in here, it just has k. So D it is. On this problem, we're given the limit as n approaches infinity of 1 over n times all of this craziness, and we're asked which of these definite integrals this is equivalent to. So this is, I mean, they didn't write the summation symbol, the sigma symbol, but this is basically summation form of one of these definite integrals. So we have to think about this as a problem where we're trying to convert a summation into a definite integral, into the form of integral from a to b of f of x dx. In this setup, the delta x is this 1 over n, and the f of x, that's all of these things, that's all of these kind of rectangle heights that are being added together and multiplied by this base that's always the same. So how do we even get started on this? Well, it'd be helpful, I mean, we usually start these problems by figuring out the integral length based off of the number above the n on this outer part here. So based on this number here of 1, that tells us that the whole interval has a length of 1, being divided up into an infinite number of pieces to get these rectangle bases. So whatever a and b are for our limits of integration, we know that they're 1 apart. Well, that doesn't narrow it down a whole bunch, but at the very least we can eliminate choice C, where the interval length is 2. If it were choice C, then this here should be a 2 over n instead of a 1 over n. Okay, so we need to figure out the a value. Now, when we're doing this, typically we see what's happening inside the function, and generally when there's a number being added to something over n, that initial number is our a value. But here it's a little difficult to tell. Is this, because what's the original function? Is it 1 over x and this whole 2 plus whatever is basically x? Or is it 1 over 2 plus x and it's just the 1 over n, 2 over n term that's the x? There's answer choices for both of these. So what I had to do on this was I had to construct 2 theories and sort of see them to their logical conclusion to see if I could get an answer choice. My first theory is, let's say we have an a value of 2. Let's say that this is 2 plus, and that the rest of this is k delta x here. Well, in that case, that would mean that my b value would have to be 2 plus that interval length of 1, or 3. So we would have the integral from 2 to 3, which looks like choice D. Well, in that case, the f of x would have to be 1 over x. This whole thing down here, because the a value would be included in it, this whole thing would have to be x. So we'd essentially have the integral from 2 to 3 of 1 over x dx. This would be a perfectly acceptable equivalent to what we have up here. Unfortunately, that is not one of the answer choices, not an option. So although this would be an acceptable answer on a free response, it's not going to cut it on this multiple choice. So we have to look for an alternate theory of how this could be converted. So the only other possibility here, or at least the only other one that there's going to be an answer choice for, is that the a value is actually 0. So when I'm seeing 2 plus here, this 2 is actually part of the original function. And what I've really got going on with my a plus k delta x term, the a value is 0, so I have an invisible 0 plus 1 over n, 0 plus 2 over n, that I'm just not seeing because we don't write 0 plus. So in this case, if a is 0, that would mean b would have to be 0 plus 1, or simply 1. And then the function itself would have to be 1 over 2 plus x. Well, that would give us the integral from 0 to 1 of 1 over 2 plus x dx, which we do have an answer choice for, and that's going to be answer choice B. For this problem, we're given this f function here, which looks pretty wild. It's also known that this is an increasing function on the interval 2 to 8. And R3 is a right Riemann sum for this thing, for the integral from 2 to 8, using 3 subintervals of equal length. So if we're going from 2 to 8 over 3 subintervals, that means that each of these subintervals has a base of 2. The rectangles are all 2 wide. All right, so we want to know which of these statements down here is going to be correct. And these statements, the main difference between them, if you look at them closely, we have 2 different possible values of R3, this 103 value and this 216 value. And the other possibilities are we have under versus overestimates. So we can actually narrow this down to 2 answer choices right away. Since they told us this is an increasing function and it's right Riemann sum that we're doing here, we know our RAM is going to always over-approximate increasing functions. So that means that we're down to choices B and D right off the bat. But we still have to figure out the value of R3. So to get that, to get the approximation of the integral from 2 to 8 of f of x, using our right Riemann sum, we're going to add a bunch of base times height rectangle areas together. The base in all cases is again going to be 2, because again, you're going from 2 to 8, that's a 6 distance total, divided up over 3 intervals. So we're going to have 2 times the y values. Well, what are the y values going to be? Each of these rectangles has 2 possible y values, depending on whether you plug in the left or the right endpoint. Since this is a right Riemann sum, given the choice between the 2 of them, we're going to have to plug in the right x value. So for example, my first rectangle goes from the interval from 2 to 4. So to get the right Riemann sum, I'm going to have to do my base of 2 times f of 4, because 4, between the x values 2 and 4, 4 is the rightmost endpoint of that rectangle. Next, we're going to have to do a base of 2 times f of 6, plus 2 times f of 8. And this is a calculator problem, so at this point I actually have to plug all this in and see what it comes out to on the calculator. So here we go. So here I am in my calculator in the y equals. I've plugged f of x into my y1, so I never have to write it again. Quitting out of there now. I'm going to do all of this on my calculator now. Now I see that all of these are getting multiplied by 2's, so I can actually write 2 parentheses and then just do f of 4 plus f of 6 plus f of 8 in here. To do those, I'm going to do alpha trace and select y1, because that's where I stored my f of x function. And I'll open a parentheses, and my first value is going to be 4 that I'm putting in there. Make sure you close that parentheses. Now we're just going to do all that again. Y1 again. This time I'll plug in 6 plus alpha trace y1 of 8. Close the parentheses twice. Press enter. And that all comes out to 216.952, which is, let's see, going to be either C or D. We need overestimate, so it's going to be D. For this problem, f is a continuous function that's increasing, and we have a table of values, certain values of f of x. Based off this, we want to figure out what's true about L, which is the left Riemann sum approximation for integral from 2 to 11 of f of x, using 4 subintervals indicated by the table. So we've got an interval from 2 to 4, 4 to 6, and so on and so forth. So which statement is true? These statements really can be classified 2 ways. You'll notice that half of them talk about underestimates, half of them overestimates. So we can actually deal with that right away. Since this is an increasing function and we're talking about LRAM always underapproximates increasing functions. So already we can eliminate choices B and D, so it's down to A and C. Now they also are classified based off of the actual value of L. we have a choice between 13.95 and 15.5. So we'll actually have to start doing things out here, Riemann sum style, to figure out which of those it is. Okay, so I can say that my integral from 2 to 11 is approximately equal to the following. So these are all going to be base times height rectangle areas that I'm adding together here. For the first rectangle, which goes from 2 to 4, I have a base of 2 times a height of, well, my possible heights are in the f of x column here, or the row here. But because this is a left Riemann sum, I always have to take the left choice between the two of them. So I have a base of 2 times a height of 0.7. Next, we have a base of 2 from 4 to 6 times a height of 1.1. After that, a base of 1, so it changes here. It's not always 2. It's 1 this time around, times a height of 1.9. Finally, from 7 to 11, that's a base of 4 times a height of 2.5. And you could leave this the way it is if this were a free response, but we need a final answer because it's not. It's multiple choice. And this is a no calculator problem. So here we go. All right, so I'm gonna go for the low-hanging fruit first. I'll start over here. 4 times 2.5, I know that's 10. 1 times 1.9 is 1.9. So I've got 11.9 for these last two terms here. Going over here now, we've got 2 times 0.7. That's going to be 1.4. Plus 11.9, that's going to be 13.3. Plus another 2.2 is going to be 15.5. And I'm sure you would actually write this out and do some arithmetic on paper, but I was just trying to do it all in my head. So there it is. That's going to be, let's see, we need 15.5 and under, so that's choice C. On this problem, I'm given the definite integral from 2 to 5 of this stuff, and I want to convert it into one of these Riemann sum formats. So in general, I have the limit as n approaches infinity, integral from 1 to n of f of x k times delta x. So I need to figure out what these two components both are. And I always start by figuring out delta x because you can always find that by looking at the limits of integration. Since I'm going from 2 to 5 here, I have a total interval length of 3, which I'm going to divide up into n pieces to get the bases, basically, of my rectangles that I'm adding together. So this is 3 over n for the delta x. Again, that's coming from my limits of integration. So now to get the x sub k that I'm plugging into my function, I need to do the a value plus k times delta x. So, and this is x sub k here. So in this case, that's going to be an a value of 2 plus k is going to stay k. You'll notice there's k's in all the answer choices here. Delta x we just found was 3 over n, so that's going to be 3k over n for that piece of it. So this 2 plus 3k over n, this whole thing is x sub k. This is giving us all the x values that we're plugging into this function. So now, what's happening to the x value in our integral? Well, we're raising it to the fourth, we're adding 1, and then we're square rooting it just for good measure. So when I put all this together, I'm going to have my limit as n approaches infinity of the summation and all that stuff. And now f of x sub k, it's going to be the square root of 1 plus all of this stuff to the fourth power. And then my dx, I'm going to replace that with a delta x, which we found to be 3 over n. All right, is this one of the answer choices? Well, it looks to be answer choice D. Does that have everything? It does. So answer choice D. For this one, we have something in this Riemann sum format, and we're trying to convert it into the form of integral from a to b of f of x dx. So let's start by figuring out the a and the b value. So in general, I have an interval length of 4, so whatever a and b are, they're going to be 4 apart. This number above n always tells us how long the whole interval is. So looking at my answer choices, since a and b have to be 4 apart, that gives us choices A or B. C and D, not so much. Okay, so now we got to narrow it down a little bit. The A value in this case is generally whatever's being added to the something k over n term inside here. So that's going to be an A value of 1. And since these are 4 apart, the B value is going to be 1 plus this 4 here. which gives us a b value of 5. So already it's looking like choice B. Let's just be sure, though. So let's see here. 1 plus 4k over n, this whole thing, whatever's happening to this thing serves as x in the integral. So it looks like it's being signed, squared, and added to 3. So we should have the integral from 1 to 5 of sine squared of x plus 3. And we have a dx there for the delta x. The 4 over n becomes a dx here. And that is looking like it's going to be which answer choice? That looks like answer choice B. There we go. For this problem, I'm trying to convert this definite integral into one of these Riemann sums. So to do that, I have to put this integral in this format here. Limit as n approaches infinity, summation 1 to n, f of x sub k, delta x. So I always find delta x first on these, because I can always get that by looking at the difference between the a and the b in my limits of integration. So my delta x is going to be 4 minus 1, that distance, all over n. Because this is basically figuring out what my rectangle base is. If I take this total distance and divide it into n pieces, which, n's approaching infinity. So these are really tiny bases. So delta x is going to be 3 over n. And then to get the x sub k, in general, that's going to be my a value, my lower limit of integration, plus k times delta x. This is going to give me all the x values that I'm plugging in here to get my rectangle heights. So a in this case was 1, and that's going to be 1 plus k times 3 over n, so 3k over n, because that was my delta x. This whole thing here, 1 plus 3k over n, this is basically x that you're seeing up here in your definite integral, your integrand. So when I put all this together, I'm going to have, let's see here, limit of all this stuff, and f of x sub k is basically going to be arctan of 1 plus this stuff right here. So 1 plus 3k over n. And then for the dx, the delta x, that's going to be 3 over n. So naturally, this is none of the answer choices, but this can actually be simplified a tiny little bit. 1 plus 1 is 2. So now this is going to match answer choice D.